Assalamualaikum warahmatullah. So today we are going to continue with our topic 2.1 hydrostatics in fluid force. So this is the references, and now we are going to look at the outline to subchapter 2.1.8 hydrostatic force on plane surface and inclined surface, and hydrostatic thrust on curved surface. So this is your learning outcome of this topic, subtopic. So what is the hydrostatic force on plane surface and inclined surface? It is when there is no movement of the fluid, so there are no shear stress present. And then the pressure exerted by a fluid under hydrostatic condition at any depth is equal. The pressure may act perpendicular to an immersed surface, and hydrostatic pressure varies linearly, increasing with an increase in depth. So this means when you have object that immersed in the water, immersed in the liquid, for example, we have a tank of water, and then we have some cube inside the water. Okay, and then the pressure may perpendicular to the immersed object, okay, in all direction. So hydrostatic force on submerged plane surface. As we can see here, when we have a dam, it is a wall of a dam immersed in the river, in the water. So we can see that the force act perpendicular to the surface. Okay, and then as increasing depth, and then the pressure may increase, meaning that higher pressure will act towards the surface in the inner depth. By consider a plane surface immersed in a liquid inclined at angle theta. So this is the surface of water, and we have the point O here. Okay, so this surface inclined, okay, with the theta angle. So we can see we have the height, okay, and then the height of the gravity, and then the height of the pressure, and then the force that act towards the immersed object. And then when we put this inclined surface into this, project this into this area, okay, we can see the center of gravity is here, and then the center of pressure is here. Okay, so this is the difference of the area. Alright, this is the area of the inclined surface. Consider an elemental strip where the pressure P is constant and the elemental force delta F acting on the elemental area. So it can write as the difference of pressure may equal to the pressure, the difference of force may equal to the pressure times with the difference of area. So as we know, the pressure is the rho GH. Okay, so pressure is rho GH, and then we substitute rho GH and times with the area, the difference of area. And by integrating the force over the entire immersed over the entire image surface. So it will give as this force equal to the rho g the integral to the area h times dA. So therefore the integral expression in the above is the first moment of area of image surface above the water surface. Therefore it can be written as, okay, so we put the integration of area in the left, so we just put this into the left side, so we simplify into AGH. So therefore the force may become the rho times gravity times area times the Hg. What is Hg? It is the vertical distance from free surface to the center of gravity of the area. So the resultant hydrostatic force F will act normal on a single point on the image surface known as the center of pressure, Cp. So what is Cp? So let's look into this diagram. As we can see here, this is the image point, okay, this is the image plane surface, and then there is the force acting towards the point, this point, okay. So this is what we call center of pressure, Cp. So there are also a force that may acting opposite direction to the F that called Fr. So this Fr may hold this image surface to, so it can remain in this position, in its position. So by referring to the same figure, taking the moment about O, okay, so the moment due to the resultant force is equal to M equal to force times with the HP over sine theta. So as we know, F is equal to the rho g A H g from previous rho g A H g. So we just substitute this into the equation and then HP over sine theta. So we will rearrange of this formula, and therefore the sum of moment due to the elemental force may become M equal to the integration to the area times with the S surface, okay, surface times to the difference of the force, because we have difference force towards acting towards the difference of depth. So we again substitute the F into this equation. So F may become rho g H dA, but H is the sine S sine theta. So from the figure above, we know that H is this one is theta, so sine theta is H over S, right? So therefore it may become H equal to sine S sine theta. So we substitute this one into S, okay, S is into H, so therefore it may have this equation, rho g sine theta with integrated of A S square dA. So therefore you just the sum of moment due to resultant force, okay, you rearrange of the formula, and then you will rewrite again, simplify, and then you give this equation. So this is for the HP, okay, stand for vertical distance from free surface to the center of pressure, equal to the IG is the second moment of area, okay, IG, and then sine square theta over area, surface area, and then the hg, the vertical distance from free surface to the center of gravity, plus hg. Okay, hg again. So again, we have different types of area. For example, rectangular, triangle, circle, semicircle. So you already know how to calculate the area for each of these shape. Okay, so for example, rectangular, we have b times d. B, the width times the depth. But for this topic, you have new knowledge how to calculate the second moment of area, moment inertia. So when we're talking about moment inertia, you need to remember this formula. So b times d power of 3 over 12. So this is the second moment inertia for the rectangular surface. So this is for the triangle surface, circular and semicircle. So we continue with example. A rectangular plane surface is 2 meter wide and 3 meter deep. So it lies in vertical plane in water. Determine the hydrostatic force and the location where it acts when the upper edge of the plane coincide with water surface, and B is 2 meter below the free surface. So we have a plane surface with a 3 meter deep and 2 meter width. Okay, so it is immersed in the water. So we have the height of gravity and height of the pressure. So this is the center of gravity, Cg, and center of pressure, Cp. Right, so this is the front view, and this one is the side view from the side. Okay, so we have the force acting perpendicular to the surface. So how we can solve this? We have area equal to 2 times 3 equal to 6 meters squared. So therefore, the height of gravity is half of the depth. Okay, as we can see, 1 over 2 times 3 is 1.5 meter. So therefore, to calculate the force is equal to rho GH times area. So rho G is a gamma, so that's why rho is 1000, and then gravity is 9.81. So it times with 1000 times 9.81, so it gives 9810 times 6. 6 is the area. 6 is the area, and also we have to times with the Hg here 1.5. So we have correction over here. So here is times with 1.5, so you get this one, 88290 Newton. So, and it's convert to kilonewton divided by 1000, so it gives 88.29 kilonewton. So let's look how to calculate the second one. B, the hydrostatic force and the location where it is 2 meter below the free surface. So the momentum of inertia for the square, for the rectangle, so we can use this formula we can obtain from this table. For the rectangular, so we have the second moment of initial area, B times D power of 3 over 12. So we just use this formula, put B and then put the H depth, okay, time power of 3 over 12. So we have 4.5 meters power of 4. So therefore, when we are vertical, it is 90 degree. So therefore, to calculate the HP, we use the formula Ig times sin theta over A Hg. So we have this 2 meter FFS. So that is the solution for example 1. So you can try this example, okay, by having the force and center pressure of circular plate with 1.5 diameter. Okay, so it placed vertically in water, and the center of the plate is 0.75 and 3 meter below the free surface of water. So by using this circle, so we have diameter 1.5, and then the height of gravity is at the center, and high pressure is the CP. So we have the side view, CG and CP. So we have to use the formula for circle, and then you have this value, and then you calculate the height of gravity. So you just put into the formula of force. So again, to calculate the location of the pressure, so you use the formula for moment inertia for circle. You can obtain from this table pi r 4 power 4 over 4. So you just put into this formula, okay, and then you just get your Ig, and then by using the theta, that is 90 degree, and you put into this formula, so you get 0.93 meter. Okay, so how about when it is 3 meter below the surface? So you have to add 3 meter for the Hg. So you know that 3 meter is for the Hg. So you don't have to calculate anymore. You just put 3 meter direct into this formula, and you get the force. Okay, so Ig, again, same formula for circle, and then 90 degree. So Ig is again you put 0.249, and then you just plus with Hg, that is 3 meter below the surface. So you have your value of 3.047 meter. Okay, so let's look into this example. We have an inclined rectangular gate with 1 meter of the width, okay, and 1 meter of the depth, okay, with water on one side is shown in this figure. So determine the total resultant force acting on the gate. So this is the F force, okay, acting on the CP, and then locate its center of pressure. Alright, so we can look in this figure. This is the gate, okay, it is immersed by 2 meter from the surface of the water. Alright, so this is the depth of the immerse, okay, the start of the point immerse, and then the height of the gravity, okay, so CG, and then the height of the pressure, so the CP. So the force will act on the CP point. Alright, so how we want to solve this? We have given the 60 degree angle, right? So the gate was tilted by 60 degree angle, and then you need to calculate the area. So area, as we can see, the width times with the depth, so we get 1.5 meter square. And then we want to know the Hg. So Hg, we must know how to convert from this theta angle, okay, to this x, to calculate the x. So we use formula sine. Okay, so we have sine 60 degree. So we have this area, this opposite x over the hypotenuse. So hypotenuse is half of this 1 meter. So 1 meter over 2, so you have 0.5. So it is x equal to 0.5 sine 60. So that is x. You put, okay, you calculate your x, you get 0.433 meter. So therefore to calculate your HG, it is 2 meter from the surface. 2 meter from the surface to this point, starting point, and you plus with your x. With your x you have calculated, so 0.433. So you get 2.433 meter. So to know the resultant force equal to rho GA times Hg. So rho is 1000, rho water 1000, gravity is 9.81, so times with the area calculated 1.5, and Hg is 2.433, so you get 35.802 kilonewton. So that is your resultant force. So now let's calculate the moment of inertia. So by having this formula, you can obtain from the rectangle moment of inertia, B times H is the depth, so 1.5 times d power 3 over 12. Right, so you get 0.125 meter power 4, and then angle is 60 degree, so you just put the 60 degree, and you have to calculate this, and you get 2.459 meter. Okay, the HP, head of the pressure, is 2.459 meter FFS. So now let's look into this example. So to determine the resultant force and the center of pressure on isosceles triangle of base 4 meter and altitude of 4 meter with oil of specific gravity 0.9 on one side as shown in figure. So this isosceles had been immersed in the water at 1.5 meter from the water surface with 60 degree angle. So let's look into the solution. So we have 1.5, it is H from this surface of water, plus H, so H is to the total depth of the gate, equal to Hg. So we want to know the Hg, so it acting on the circle center of gravity, plus the y is to the bottom of the gate. Okay, so we will rearrange of this, so we may leave the Hg as the unknown and y. Alright, so the next one, we need to do another equation with the unknown of z and hp. So 1.5, okay, plus the h equal to hp plus the z. Alright, and then we put the force equal to rho g ah. So a is half of the 4 times 4, depth times depth, width. So it is a semicircle, it is a triangle, so therefore the formula for area for triangle is half of the width times depth, so it's get A. Alright, then for sine 60 degree, so how you get this? Again, look at this figure. So when we have this, okay, so when we have the 60 degree, so we want to know the h. So by transfer this 60 degree, so we have sine 60 equal to opposite side over this one is the 4 meter because it is the depth of the triangle, so over 4, so h is 4 sine 60, so we get 3.464 meter. And then you need to calculate the center of gravity. Center of gravity for triangle is 2/3 times 4. Times 4 is the depth of the triangle. So therefore, we get 2.667 meter square. And then we also need to calculate the y. So now we transfer the 6 degree here, okay, to this direction. So now we have y here as opposite. So sine 60 equal to opposite, that is y, over the hypotenuse. What is hypotenuse? It is the 2/3 of the center of gravity. So we have calculated before, 2/3 of the center CG is 2/3 of the 4, so 2.667. So you just over 2.667. Alright, so now you have your y is 2.667 times 60, you get 2.310 meter. Now you just put all this value h and y into the hg formula, so you calculate the hg, you get 2.654 meter. So we already have hg. Now you need to calculate your force. So force, here we have some correction because it is the soil, or it is the oil. So Sg for oil had given in the question. The question saying that Sg is 0.9. So Sg for oil, how we going to calculate the density? So Sg is the density of fluid, liquid over density of water. So it is given 0.9. So the rho of water is 1000. So you know the density of liquid oil is 900. So we use 900 to calculate this thing. So F equal to rho 900 times with the gravity times with the 8 and times with the this one. So you need to calculate again. So you will get your F, your new F. So this is by using 1000 density of water, so it is wrong because it was in the oil, so you need to use the Sg for oil. Okay, so now we need to move to the next by calculating the Ig, the moment of inertia for the triangle. B, the depth times the h power of 3 over 36, so you get 7.111 meter power of 4. And then you just put your Ig into the equation. So Hg is also already get from the previous. So you just put all the values in this formula and you get 2.905 meter.